Hello, hello. It's been a crazy 2 days. I'm so sorry. Had some issues. Hopefully now it's working. Sorry, I know that this week is crazy. We're preparing for this final exam, among other things with your other classes. I know that it's, quite hectic. Just posting the links again. I'm not going to take too much of your time, but I definitely want to make sure that I get to some questions. So I hope that you're out there. Let's test. All right. Who's out there? Anyone? I hope you guys are out there. If at least one person is out there, then I will hold a session. Who's out there? Oh, Zaid. Good morning. Glad that you can join the party. All right. I know that we're starting a little bit later today, but I just had some issues. Since you're there, can you post what question you want to look at? And hopefully the board is working. If you can just look at the whiteboard and make sure that it's working, and if you can just post the word that's there. Hey, good morning, Karen. Can you just confirm that the board is working? If you can just go to the board, if you can check, and if you can just write the word, and then I'll continue. Yes, thank you, Zay. That's what we need. That's what we're doing, right? That's what's happening today. Trying to, take steps in the right direction. Okay. All right, so I'm here for you. Whatever questions you have, I'll try to answer them. So if you don't have a question, I can definitely try to go over like a question or two. Things that you should know how to do. Let's see. All right, let's look at 24. Let's look at 24. So we look at 24, what we have to do is the following. It's f of x is equal to negative x squared plus 2x plus 15. So at this point, I urge you now to use your resources. I would go to Desmos. I think that might be the quickest thing that you can use. And you can just copy and paste this equation into Desmos. And I'm going to do that on my end. And if you have a graphing calculator, I would use that also. So if you plug this in, right, okay. So if you plug this in, you'll have something like this into Desmos. You're looking at this graphically, right? So per the graph, you have something that looks like this. There's going to be an intersection here and here. So what you need to do is identify these points. So if you use Desmos, you'll see that it's -3, 0, and 5, 0. So we've labeled these points of intersection. We call these the zeros or the roots. So these are the zeros or the roots of this quadratic equation. But then, if you use Desmos, you'll have this point up here, which I'll color differently. And this is the point 116. So the question is asking this. The question is asking, graph the quadratic function indicating the intercepts and vertex, right? So if we look here, what I've circled in blue, those represent the x-intercepts, or the zeros. Or basically, if you were to solve this equation, right? So I'm just using the board here. So if you were to solve this equation with -x squared plus 2x plus 15 equals 0. Oh, let me rewrite that. X squared plus 2x plus 15, all of that equals to 0. If you were to, again, I would divide a -1 out of here. So then you're left with the following. X squared minus 2x minus 15 equals 0. So basically what you want to do is you want to look at the factors, right? The factors of 15, that will give you -2. So the factors of 15 are 5 and 3. But to get a -2, you need a -5 and a +3. So when you solve for this, x will equal to 5 and -3. So when we go back to the graph, you'll see that you have -3, 0. Again, that's a 0 or the x value that we solved for. But it intersects the graph at this point -3, 0. But 0 being y, that makes sense because f of x in this case, or that output, is 0. So we have -3, 0, and 5, 0. The vertex, or basically the turning point of the graph, is the tip, if you will. So in this case, we have a maximum. That maximum point is 116. So we've answered the first part of this question. The second part here is describe the domain and the range. Well, the domain should be pretty clear here, right? So the domain goes from -infinity to +infinity, right? But now our range is limited, or our range peaks, right? It definitely goes all the way to -infinity, but we're going to peak at 16. So hopefully you saw that. But again, this was also provided in the solutions. Another thing as well, it's just something that you need to consider, or something that maybe you've noticed, and this was confirmed by LaGuardia. The solutions in the review sheet are incorrect. Some of them are not right. So I'm waiting for the updated version. I think the majority of the solutions are correct, so I wouldn't be too concerned with that. But hopefully that's now clear. So I went over that question. I can go over other questions if you have any. And I apologize for the noise. It's just, the neighbors are having their landscaping done, so it's a little tough. A little tough to tell them to stop, with the lawnmower. So now I'm waiting for you. If you have any questions, I'll give you another 30 seconds. If not, I'll just continue with what I think are, potential questions that, could be given to you. I'm going to go over 36E. So we're going to look at 36E. This is similar to a question that was given to you, I believe, in the practice final exam. So you had a practice final exam. The purpose of that was so that you get used to how to input values into Lumen Learning. So very similar to how you did homework. The only difference now is when you upload work. So you can do all of the math. Again, I'm so sorry, it's just so loud here. Again, you can do all of the math within the actual body of the question box, right? Because I believe that when they propose a question, I'm so sorry. When they propose a question, right, you'll have space to write. So in this space, I'm sorry. Oh my God. So in this space that you are given to write your response, you can write out everything. If it's some type of word problem, you can write out in paragraph style, or you can take a picture of your work and upload that. So I think that might be the best course of action. So you had a question like this. You had log base 2 of x. Something very similar to this was on the practice portion. So remember how you can rewrite this. Remember the rules of logarithms. Remember those rules. So when we're adding, right, you can rewrite this as a single logarithm where you have log base 2 of x times x minus 2. All of this will equal to 3. Remember, what power of 2 will give you this expression? In other words, x times x minus 2. 2 to the power of 3, now rewriting in exponential form, will have the following. We know that's just 8, so now we can just distribute this, and we can solve for x. But don't forget, when you solve, again, you can use quadratic formula. That would be the recommended route to go, just because it will always work. And again, it depends on what the question asks. It may say, do this by completing the square, do this by the quadratic formula, do this by factoring, factoring by grouping. You could be asked to do one of many things. But in this case, they're just looking for you to solve for x. It's not clear. If you forgot how to factor, if you forgot how to do factoring by grouping, if you forgot how to do how to factor when a is greater than 1, and again, that's the AC method, the quadratic formula will always work. So, factoring here, what factors of 8? When you subtract, will give you negative 2. We know that we have 4 and 2, but if we have a negative 4 and a positive 2, then that will give us not only the negative 8 when we multiply those together, but when we combine, it will give us a negative 2 through addition, or if you just do 2 minus 4. So solving x is 4 and negative 2. However, we need to check this, right? So we need to go back to our logarithm. So if we look at the following, so log base 2 of 2. Oh wait, what do we have here? I'm so sorry. Negative 2 plus log base 2 of negative 2 minus 2, will that equal to 3? So you can check this. You can use your calculator to check. But I believe when all is said and done, this value here will not work. So if you just put this into your calculator, so again, hopefully you downloaded this. Hey Edgar, good morning. Thank you for joining me. I know that we started a little bit late today, been having some tech issues. So again, I would confirm that this does in fact work. So again, you can go to math, go to find log with the base, So you put log base 2 of negative 2, and you add that with log, again, the log button with the base is in math. Math, and it should be letter A when you scroll down. Log base 2 of negative 2 plus log base 2 of 2 minus, or negative 2, excuse me, minus 2. Don't forget the negative symbol. Negative 2 minus 2, not the minus symbol. So, if you try to do that in your calculator, it'll say error, non-real answers. So, this will not work. So when we try 4, log base 2 of 4 plus log base 2 of 4 minus 2. So what power of 2 gives you 4? So that's another question here. So if you evaluate this, what power of 2 gives you 4? It should be 2. And then 4 minus 2 is 2. So what power of 2 gives you 2? That's 1. So 2 plus 1 does equal to 3. Who's out there? Gianni, good morning. Good morning. Thank you for joining me. I know that we started a little bit late today. And thank you for your flexibility. So I'm just going over some select questions here. So what we should be able to do is the following. You should be able to complete the table. Questions 41 and 42. So we'll go there quickly. So let's look. So if you're able to complete the table, so I'll complete it for one of them. So we have theta, but I want to put that in degrees also. So pi divided by 6, still using the whiteboard. I need to give myself more room here. Sorry. Pi divided by 6. We also have pi divided by 4. And then lastly, pi divided by 3. But don't forget, you have pi is 180, so 180 divided by 6 is 30. 180 divided by 4 is 45. And then pi divided by 3, that's 60 degrees. So don't forget, 30, 45, 60. So what I would do if I were you, I would set up a triangle, like I have here, and we can start with 30 degrees, right? So remember, 30, 60, 90, right? And this implies your unit circle, right? The unit circle. So remember the ratio. Remember the ratio. 1/2 radical 3. All right, so hopefully you remember this. Right, so if we have, again, 30, if that's the angle in question, right? So if you have sine of pi divided by 6, that's the same as sine of 30 degrees. So if you do opposite over hypotenuse, you should have 1/2. And you should be able to confirm that in your calculator. So if you put in sine 30, you should get 0.5. And you should just do that quickly for good measure. And good practice also utilizing your calculator. Make sure that you are in degree mode. You must be in degree mode. So being in degree mode, you'll have 0.5. So you can easily figure out what cosine of this is. Cosine of pi divided by 6, or cosine of 30, and that should be radical 3. So if you put in radical 3, the square root of 3, You should do that now. And when you hit enter, oops, I forgot one thing here. It should be radical 3 divided by 2, excuse me. Remember the side opposite. Remember the side opposite 60 degrees is radical 3 times larger than the smallest side. So I forgot to put that there. So again, we have cosine of 30 degrees, which should be radical 3 divided by 2. So, one second here. So in your calculator, I would put that in. I would do radical 3 divided by 2, and then put in cosine of 30 degrees. And if you do that, they should both equal to about 0.8660, something like that. And we'll do tangent. So we do tangent of 30 degrees. Again, this is dependent, and that's the same thing as tangent of pi divided by 6. So you have to refer back to the figure. So after you've labeled the triangle, so let me label this again so you can see it. So I have it here. So this is 30, right? So we said this was half, this is 1, and this is radical 3 divided by 2, opposite 60 degrees. So right now what we're going to do is the following. So we're going to compare with respect to 30 degrees, opposite, right? 1/2 divided by radical 3 over 2. But if you look at this is kind of complex, and we can simplify it, and then we're left with 1 divided by radical 3. But remember, we cannot leave it in that form. We have to rationalize it. So if we do that, it'll be radical 3 divided by 3. So we do tan of 30, we hit enter, and then we do radical 3, divide that by 3, we should have the same response. And that ends up being about, what is it, 0.5774, roughly. So that's how you find tan of, or pi divided by 6. So if you go tan pi divided by 6, we did that. We did that for sine, also pi divided by 6. Cosine, pi divided by 6. But we could also do this with pi divided by 3. But that's just 60 degrees. So if we look back here, I can put 60 degrees here if I wanted to. And now this is 30. We know that opposite 30 is half. Across from the right angle is 1, and opposite 60 is radical 3 divided by 2. So now we have the following. So if we're looking at, let's see here, if we're looking at tan of pi divided by 3, if we're looking at cosine of pi divided by 3, and then lastly sine of pi divided by 3, this is the same as tan 60, same as cosine 60, the same as sine 60. And we use the chart to help us. So we can easily do cosine of 60. That will equal to 1/2. Sine of 60 is radical 3 divided by 2. But now here, when we compare tan 60 should just be radical 3. Because again, that's opposite divided by adjacent, and radical 3 divided by 2, if we take half of that, it's just radical 3. So hopefully that was a little bit clear. Do we have any questions? So I went over some stuff. Again, tomorrow I will make myself available. If you guys need any assistance, just please email me first thing in the morning and I can try to assist you. I have not received any information yet as to when the exam will go live. I haven't received it, not as of today. So I don't think it would be fair to give you the final exam on Friday. If anything, it's going to have to be Monday or maybe even Tuesday of next week. And again, that's dependent on when they give me the exam. So I would continue to prepare for the exam, go over the questions, compare to the solutions, and I'll continue to review this with you on Friday. And again, we'll meet normal time on Friday. Hopefully I don't have any issues whatsoever. I'm just trying to think. Tomorrow, though. Tomorrow I can make myself available. I can be available as early as 7:30. I'll be available most of the morning from 7:30 till about 8:30 if you have any questions. If you need me to be available a little bit earlier, I'm up, by 7 a.m. I'm, ready to work. So it's up to you. If you have a question at that hour, please feel free. If you have any questions throughout the day, please feel free to also email me. I'm around. And I definitely want to help you, and I want to make sure that you're ready for this exam. So if there are no more questions, I'll end this for today. Again, I wanted to make sure that I at least met with you for about a half hour. Please make sure that you go into Lumen Learning and you attempt the practice final exam. This way you get used to the format, the style, how to input answers, how to upload images as well to Lumen Learning. I tried looking for student work today. I didn't see it, but I'm going to go back and I'm going to try to explore that a little bit further. So on that note, if you have no more questions, I'll be around throughout the day. I'll be around tomorrow morning, but if you don't need my assistance for tomorrow morning, I'll see you on Friday. So until then, enjoy the rest of the day, and I'll see you soon.